Coming up on the next episode. Good Saturday to you all, YouTube. It is 3:06 now in the afternoon. This is the 27th of February, and one more day, which is Sunday. And then Monday marks the new March 1st, and that's always a good thing. It's payday for me, so that's always real good. Here today to talk about the MFP. Some possible holes so we can get this thing finished up and get it into production or into use, I guess I should say. Let me bring up this screen here. Now we're going to start on the DDC-PS2 end to look for items that possible holes needed for the front panel jacks, fuses, and switches for the MFP. That is our title. Under the DDC-PS2 is 2 output banana jacks, red and black. Those will be our main power out. 2 switches, a main power, and a rotary 4-pole double throw for the dual voltage. And the 1 or 2 possible fuses. Now if we look at the diagram, we can see that, there is a possibility for 2 fuses. One is the main power fuse here, which is a 2 amp, and the secondary fuse is over here in the high voltage circuit. And I'm thinking right now this is a 1 amp. I've got this marked as a 1 amp slow blow. I think we can do without this one and just use the 2 amp. For our protection. I don't think there's anything here that would cause any problems if it exceeded the 1 amp temporarily. I don't really think it would be a big deal. So, and if it is, we can add that later. But I think for now we're going to avoid that fuse and just go with the 1 fuse for the 2 amp power. And that will be all we need. Now the switches, if we look at that, there is our main power switch right there. And here is our rotary 4-pole double throw switch. And when I say double throw, it's actually 2 throw with it off in the middle. And it's just made for, sometimes they're made that way, and that's just the way this one happens to be. But like I said, it's like the other ones, the old DDC power supply, but it has more poles to it than the other one did, I guess is what I'd say. So there's our look at that one. That's pretty much going to cover our first one for that, and I don't foresee any other necessary items for that. And so if that's the way that works, I think. So let's go down and move one more over. And if we do that, we're going to come up with our AC voltage meter. Now this is the little voltage meter that the 10 volt AC meter that's going to be used for alignments. And right now I don't see anything necessary for that except for 2 input banana jacks. And they are going to be yellow in color because it is AC that is being inputted. So those will just go out to a pair of clip leads, so I can clip on a speaker or whatever I'm using for the device to measure the voltage, so I can do the alignments, things like that. That's all that's going to be. So that was pretty simple. So far, if we look at this, like we've got 2, 4, 5, 6, 7 holes so far. Now these are all going to be done one at a time, so it's not a big deal, but I just kind of want to go over them real quick and see what we're looking at as far as total holes. Now the next one is the XR2206 function generator. I have listed 1 BNC jack, which is going to be our main output. 1 SP double throw, single pole double throw switch. This will switch between the sine or triangular wave. and the square wave. In other words, switch it one way, it will be sine or triangular, depending on how the jumper is set. And switch it the other way, it will have a square wave output. So that's pretty much simple on that. Now, there is some complications of that, which we will discuss later. But for right now, we're going to just count that as 2 holes for that. And now we're up to 9 holes, I guess. So go on down the line. Filament transformer. Now, this is the elephant in the room that we don't discuss much because basically it's kind of out of sight, out of mind type thing. Let me see if I can find the diagram for it. Alright, well there's our diagram for the filament transformer. And that is basically how it's wired up. And for this particular scenario, what we're using is 2 outputs. The output from 5 and 8, that will be our banana jacks right there. And there will be another hole for a switch, a double pole, double throw switch, which will be wired in this fashion here. And doing it that way, one switch position will give us 6 volt AC, total of 4 amp output power if we need it. And the other way will give us 12 volt AC and a total of 2 amp output. So that's how that's going to be wired. That's the most logical, most useful way that I could figure on doing that, and it gives us the most versatility, I guess is what I'm looking to say. And so that's how that's going to be done. So if we move on down our list again, frequency counter. Now this is a simple, very simple one. One input BNC jack. That's just going to be, like I say, BNC to put in frequencies into the frequency counter so that it can be counted. Those are gonna be a coax cable with clip leads probably of some type, and those will just, like I say, input the whatever we want to measure into the frequency counter. That's pretty simple too. Let's go on down one more. The DSO38 oscope, 1 output BNC jack. It's the same thing there, just an output jack instead of an input. They're the same jack though. So all of the functions of the, and that's something I forgot to say about the frequency counter. It has functions, switches, but they are on the module itself, and they are accessible with the holes I put in there. So again, the oscope is the same way. It has all of the functions settable from the scope top itself, which is going to be visible, and you can get to that easily. So the only thing you really need is the output jack. So that's that. Another pretty simple one, I think. The DMEM, on the end there, is none required. It has all of the jacks it needs on the DMM itself, and that will be totally accessible from the top there. And so that is, again, nothing required. So that's good. Now the signal tracer is going to depend on how I end up making it. In other words, which design I end up using. I still have a lot of experimenting to do on that, and right now it's either going to have an input BNC jack for a tracer like the BDST, or it's going to have a hardwired, or even a possibility of a jack system on that too, per stereo cable. And I can use, like I say, a 3.5 millimeter stereo jack and plug for that if I want to do that, to where it will be pluggable, the probe, and that can be done. So not a big deal one way or the other, but anyway, it will be one or the other. Pretty sure that it's only going to be one hole either way we go. So that's that. So that ends the discussion on how many holes we do. So if we count them up, we have 1, 2, 3, and 3 more there. That's 6. 2 there is 8. 2 more there is 10. And I think I came up with 4, 5, so 15. Basically 15 holes that I've got to add for the different components on the MFP. So that's the way that's going to work. So now on this function generator, I had Don had a diagram that he made up you guys may recall he did a video on it, and it was adding modulation to this function generator, this particular function generator, and it really caught my eye because it would be a quick and dirty use of that. In other words, I have better ones like the HP, and I even have on the transistor analyzer, radio transistor analyzer, transistor radio analyzer, whatever it's called, the B&K 970. That's going to be on the other end of the bench, has an output for that as well. So, you know, it's nothing. It would just be a means if I wanted to see what something's doing without having to fire up either one of those big machines. I can use this and be perfectly, you know, good with it because, like I said, it will work. So let's look at that real quick. All right, if we look at Don's main schematic for this, it takes basically a Bluetooth receiver unit, which mine is going to have the actual receiver on the board. There won't be a jack here, anything like that. It will have the capacitor, I think, but other than that, it won't have anything like that. It will go to a single pole double throw switch. One way switches it on, one way switches it off. Don's circuit is very simple because normally this pin 1 of the XR2206 chip is grounded. So basically that's what it's going to do if it's switched this way, it grounds. And that's just a normal operation for it. Now if it goes this way, then we get our little voltage divider here and we get our operation. So like I say, it just adds voltage to the circuitry coming in here, and like I said, that's all that's necessary. So that's pretty simple. Now here, the complicated part was in how I handle the output. Don's output is got another circuit on it. If we look at that, now this basically cleans up the harmonics when it's used as a broadcaster type of circuit. In other words, if like Don did a demo of where he had music playing over it, and that's what you would use this for. So, you know, unless it's used for something like that, this circuit is not really necessary. Because mainly what we would be using, I would still use it with my phone, but I would use it with tones. There's a frequency generator program for the phone, app, what do you want to call it, that will let you basically just output a 400 or 1K tone over the modulation, and that's really all probably everything would ever be needed for this, because that's basically all you're going to do is be in a simple test. Again, if I did want to do this, all I would have to do is add this capacitor and this coil to a circuit and just basically put that in between the output to where, or on the output I should say, of whatever I'm feeding. In other words, if I have my clip leads there, and I can just clip that to that and go in between that and the antenna. So basically that's all that's necessary for that. That's not really something that needs to be switched in or out, or, you know, because 9 times out of 10 it's not even going to be used. So looking back at the other one again, you know, we can basically, I can go ahead and include this because this will be done that way. So there will be another hole for that. So I think we're up to 16 holes now. But again, that's easy thing to add. I have plenty of those switches, and so those will be easy to add. They're just round holes is all they are. It's very simple, easy to do, and so that's all we need to do for that. In addition to that, I did do some wiring. I said wiring, not really wiring, but let me show you what I did. Last night I was sitting at the bench doing this and that, listening to music mainly, and I thought, you know, I need to get these wires separated for the power transformer, and that's what I did. I made little labels, line in, this is our red, black, and our black wire coming into the power transformer, and those are our line in. Over here we have high voltage secondary out. That is a red and white and a red, and those are separated and marked. And the last one is the secondary center tap. All these connections here that are marked are the ones that will be used. Now the ones that are taped off here with our wire nuts and stuff like that to keep them from being used or shorted or anything like that are our filament windings on this transformer. And originally, of course, it came with filament windings. It was used in a radio, after all. But we're not using that. We have our own dedicated filament transformer. And this one would really not be very helpful because it's on a variable supply, and the filament voltage would vary pretty widely, so we don't want to do that. We're not going to use those at all. So that's how that's going to be done. And like I said, I want to do the same thing with the variac and the filament transformer, get those all lined up, ready to go, and all I have to do is join the wires together, solder them, and heat shrink them, and that will be all that's necessary. There's a possibility, and I haven't really thought of it too much yet, but I may use connectors on these to keep it all modular, much like I'm using on the DC part of this. And let me show you that real quick. There's our power distribution guide for the MFP. Now this is a 9 volt and 3 volt for the low DC voltage distribution. You can see here's our little board that we made up. Now I did make a change in this. This device here and this device here is not being used. I have just mounted the barrel jacks for the wall warts here, here, and here. So basically our 2 amp will be on top here, and it will feed this bus bar here, which will in turn feed this, and all the circuits here for the 9 volt. You can see a 9 volt signal tracer, 9 volt oscilloscope, a 9 volt frequency counter, and 9 volt signal generator. So that's all our outputs for those. And those will all have the little plug-in things that I bought for that. And the 3 volt will have its own separate different, I think it's a Molex connector that I bought for it, so that we don't get confused and plug in the wrong thing to the wrong place. So all that's going to be modular, as it were. So I can unplug all this and get everything attached or disattached, as needed. The same way with the barrel connectors, I can unattach the wall wart connectors from those, and this will all be separated. Now that's what I'm thinking about doing with the this one, and having all the AC power be able to be separated, instead of having things hardwired in, because once you hardwire like this to the variac, then you're stuck with it. You have to, if you want to take out one or the other and work on it, you have to take, either cut the wires or something of that sort. And I'd just as soon have connectors between those. If I can find suitable ones for AC, I will probably do that. And it just seemed like a better way of doing it to me. The whole high voltage section and the secondary center tap will go to the switch, the rotary 4-pole double throw switch. And so I don't know about making connectors for it, but we'll think about it. Like I said, I would like to have all this modular as far as being able to take it out. It would be really handy to do. Same with the filament transformer. It will be hardwired into, or use a, when I say hardware, it may use a connector, but it will have its own switch, as does this section of the dual DC power supply. Will be switched to have a main power, and as will the filament transformer will be switched on and off from its own switch. And for the rest of it, now these will all plug into one central line that will go over to the bench distribution power. In other words, all this MFP stuff will go on and off with the power switch from the bench. When I turn the light off, all this will be disconnected. It will be nothing left on at all in this MFP. So that's how I'm doing that, and I've always tried to get everything on my bench wired into that, so that way I don't have to worry about it. When I leave the room or turn that light out, I know that everything is off, and I really don't have to worry about anything being left on that way. So that's what we're trying to do with that, and I think it should work out really well. Like I say, I'm planning on using on the the one for the low voltage, the wall warts. There's 3 of those wall warts, and I think I can use a extension cord end. You guys have all seen the extension cord ends with 3 plug-ins, and I'll use a wire like that, plug in the wall warts to that, and that will be wired via probably a connector to the main power, which goes to the bench distribution power, switched on the light switch. So that's how that's all going to be done, and I've still yet to work all that out, but that's coming up pretty quick. I'm getting closer to the end, and I'm really happy about this. This is something that's been I've been working on this for quite a while. You guys that's followed along knows, and I want to see this come to fruition. I want it to work. So like I said, I'm really kind of trying to get back on it and get some things done. And like I say, if you guys have any kind of suggestions on the things that we've just gone over, be sure to let me know in the comments. And like I say, I like when you guys suggest things. It makes me think a little harder about what I'm doing, and is it a good idea, is it a bad idea, things like that. And I may not always implement ideas that are suggested, because I have either a better way in mind, or it kind of comes down to what I think is best as far as it's my project. But at the same time, I have in the past been convinced otherwise. So by all means, please suggest something that if you have something you think will work better. I'm ready to listen and learn and things like that. And so that's basically it. I think we're going to get off here. I'm probably going to work on this this afternoon maybe, and maybe try to get some of the new power wires in for the Variac. I think that's going to be used with the clips, where it's got the terminals where you can just push the terminals on the Variac itself, and then wire it in like I talked about with the connectors. So going to be looking at that today, and if you have a suggestion for that, I don't know how much I'll get done. If you have a suggestion for a good AC type connector that would work in this situation, please by all means let me know. So alright, I think we're going to get off of here and get some other stuff done, and I hope you guys have a great day. Thank you so much for watching, and we will see ya.